Look at the speed of a modern automated logistics center. It is a complex system moving thousands of packages a minute. When you first learn to write code, maybe setting up a simple Python loop or writing a basic function, it can be hard to connect those small foundational blocks to this level of global commerce. In a corporate environment, a business manager might never write a single line of code themselves, yet they are the ones held entirely responsible for the software that runs their department. They have to ensure that the digital tools their team relies on actually drive efficiency, rather than bogging down the workflow. Software procurement is a strategic matrix. Every choice made here dictates how an organization operates, competes, and scales over its entire lifespan. Choose the wrong system, and your company risks total operational paralysis. Making the right choice builds a structural advantage over your competitors. This decision tree starts with a business need. The first branch is packaged software, like QuickBooks, which deploys immediately. The middle branch customizes software, like adding custom privacy modules. The final branch, building in-house, like Basecamp, yields a perfectly tailored proprietary project management system. Whether you buy, customize, or build, that single decision sets a company's financial risk profile and determines its operational flexibility for years to come. Once a business chooses to build or customize software, the creation process begins. Without established frameworks to guide developers, a large programming project quickly devolves into expensive chaos. Organizations use the Product Development Lifecycle, or PDLC, to filter raw concepts into an approved business strategy, determining if an app is financially worth building. Then, the Software Development Lifecycle, or SDLC, handles the technical execution, designing architecture, writing code, and testing results. The PDLC answers if a product should be built. The SDLC dictates how to build it. Large software projects collapse when the business goals of the PDLC fail to align with the technical realities of the SDLC. Within the SDLC, the development team follows a specific methodology, operational rules that dictate how the code is written and reviewed. These heavy vault gears lock sequentially, the Waterfall methodology. It's highly structured. You cannot move to the next phase until the current one finishes. When coding a bank security system where requirements are fixed and failure is not an option, you use Waterfall. In contrast, this continuous loop represents the Agile methodology. Agile emphasizes repeating cycles of development and testing. This is ideal for a food delivery app that requires constant weekly updates based on real user feedback. Eventually, the code reaches black box testing. Managers evaluate the software purely based on user experience and outputs, without needing to understand the underlying code. Selecting the right methodology and testing protocol is a critical exercise in limiting financial exposure. These steps provide a financial safeguard while the project is in its most expensive coding phase. Once the software clears testing, it is ready for deployment. But rolling new code out to an active company carries extreme operational risk. A bad update can freeze an entire organization. Managers use specific methodologies to manage this risk. The Big Bang methodology replaces the old system with the new one all at once. Imagine upgrading a government agency's entire email system over a single weekend. It's fast, but if something breaks on Monday morning, the agency stops working. This timeline shows the parallel run strategy. Both the old and new systems run together. Employees process new digital forms while filling out legacy paper ones, providing safety. The pilot release tests a single node, like one retail store, before cascading into a national rollout once stable. A launch strategy is a fundamental risk mitigation tool. These deployment schedules exist to prevent the operational paralysis that can occur when new code hits an active organization. Even after a flawless launch, the work continues. Software is a living system. It requires continuous maintenance to survive. Sometimes that means corrective maintenance, where developers patch active bugs. Other times it means perfective maintenance, adding new features to improve the user experience based on real-world interaction. Eventually, the software faces adaptive maintenance. This is forced evolution. When a mobile operating system releases a major update, your company's app must be modified to function in that new environment. Look at the contrast here. A local coffee shop's needs look very different from a massive server farm. But in both cases, business professionals guide the technology. Think about a business you interact with every day. Based on operational needs, do they rely on packaged software or a custom-built, and why?